Hi guys! We're back with lesson 4, writing products as sums as products. So we were doing some work on this with the last lesson, so it might seem familiar. Um, your objectives are to use an area model to write the product as a sum, as sums and sums as products. You're going to use the fact that the opposite of a number is the same as multiplying by -1 to write the opposite of a sum in standard form. Remember, that's the form where we combine all the like terms. You're going to learn to recognize that rewriting an expression in a different form can shed light on the problem and how the quantities in it are related. So let's look at example 1 here. So normally in class I would give you 2 minutes to write equivalent expressions using the distributive property for the first 4 problems. Then I would ask you to try to factor out a common factor and write an equivalent expression for the last 4. But you guys aren't in class right now, so for A, let's just look at a couple of these really quick. For A, we have 2 times x plus 5 would be 2x plus 10, because the 2 is also going to be times 5 as well as x. So don't forget that. 2 times 5 is 10. For 3, we have 3x plus 4. Same deal. It becomes 3 times x, and 4 times 3 is 12. So we get 12. For 6, times x plus 1, it's 6 times x, but 6 times 1 is 6. For 7, 7x minus 3. That's interesting because we've switched our sign, but we can still do it. Because 7 times 3 is 21, and we have 7x. Okay, so for part 2, what they're asking you to do is reverse this. So 5x becomes 5 times x, and 30 becomes 5 plus 6, because 5 and 6 are the factors that make 30. You do the same thing for this one, 8x plus 8. So 8 times what equals 8? That is 1. And 8 times x. 3 times what equals 3 times what equals 12? Well, that would be 4. And 3 times x. 15. This is an interesting problem they threw at you here. So we have 5 times 3 times x. So 5 times 3 is 15. And we don't know what x is, so that's still 15x. So 15x, to create 15x and 20, we have to have 3. Because 3 times 5 is 15. 3 times 4 is 20. That's a little tougher, but you can think in reverse like that. You're supposed to find the factor that is in common with all of these. That's how you figure this out. Okay, so what is happening when you factor and rewrite the equivalent expression for parts E, F, G, and H? In the same way that dividing is the opposite or inverse of multiplying, factoring is the opposite of expanding. So up here, we were expanding our expressions. This is expanded expressions. This is standard. Here, we had our standard expressions, and we expanded them. What are the terms being divided by? They are being divided by a common factor. Common factor means they have the same factor that divides or multiplies by both of them. Okay, let's move on. I'm going to let you do exercise 3 on your own. If you need to look at the answers, go ahead, but I do expect to see your work and your process. The answers are there to help you if you get stuck. So you can go back and pause the video there if you need to. In this example, let the variables x and y stand for positive integers, and let 2x and 12y and 8 represent the areas of the three rectangles. So here's 2x. It would help if I was on the right layer. 2x, 12y, and 8. The goal is to find the length of each individual region with areas of 2x, 12y, and 8, so that all regions have the same width. Let the variables x and y, okay, and what does 2x represent in the first region of the array? The region has an area of 2x, or can be covered by 2 square units. So essentially, we could split that in half, and that would be our 2 units. But y is not x. What does the entire array represent? The entire array represents 2x plus 12y plus 8 square units. Okay, so let me move up here. What is the common factor for 2, 12, and 8? The common factor for 2, 12, and 8 is 2. Because you can divide 2 into any of those. You can multiply any of those. You can multiply by 2 to get any of those. What are the missing values, and how do you know? Well, 2x, so 2x, that means this is x and there's 2 of them. So you have 2, right? 6y, so you'd have 6y in here, and 4 8s. Why 4 8s? Because that was what you would do by 2 to get 8. Why 6y? Because that is what you would do by 2 to get 12. Okay. If you wrote the expression as a sum and then a product of two factors, 2x plus 2y plus 8, 2 times x plus 6y plus 4. How does this exercise differ from the exercise we did during the previous lesson? How is the exercise similar to the ones we did during the previous lesson? We are doing the inverse of writing products as sums. Before we wrote a product as a sum using the distributive property. Now we are writing a sum as a product using the distributive property. That means our plus, it changes to pluses and a times. So that's where we get our product from, because this is 2 times x times 6y times 4. And that is where we are changing. Okay. I think it's going to cut me off here, so I will be back for the next video.